Good morning, sir. I am Tanishq Tiwari, and today I will be talking about an important concept in an operating system: memory management. Uh, it's one of the core responsibility of an operating system, and by the end of this presentation, you will understand how it works and why it is crucial for system performance. Let's begin by looking at the table of contents. Uh, Here's what I'll be covering today. What is memory management in an operating system? Why do we use memory management? Key techniques used and important terminologies. Let's start with the basics. What exactly memory management in operating system actually means. To begin with, we have memory management is a function of an OS operating system handles primary memory. It tracks every memory locations whether it's free or in use. When programs run, the operating system moves them between the disk and RAM, ensuring the processor always has access to the necessary data. This becomes especially important when we are running multiple programs at once. The operating system must manage memory efficiently so everything runs smoothly. In short, it's all about organizing memory for efficient and stable performance. Now that we know what it is, let's look why it is so important. There are several key reasons for using memory management. It decides how much memory to give to each process. It keeps track of free and allocated memory. It ensures that applications don't interfere with one another. It protects data and support efficient multitasking. And it makes sure memory is used to its fullest without wasting space. All of this contribution to better performance and system stability for the user benefits. With that understanding, let's now explore the different techniques used to manage memory. There are general tasks done by memory management techniques. Allocate and deallocate RAM among multiple programs, keep memory usage optimal and prevent wastage, track memory blocks used and free, avoid memory leak and fragmentations, and provide virtual memory which gives the illusion of more memory than is physically available. Let's look at the specific techniques for more detail. Here are the key types of memory management techniques used in an operating systems. There are two categories: contiguous and non-contiguous memory allocation. Under this we have single contiguous allocation, partitioned allocation, page memory management, segmented memory management, multi-programming and uniprogramming. Let's go over each one of quickly. Now let's understand how each technique works. In a short manner, first we will discuss single contiguous allocation. Only one process is loaded into memory. Simple but outdated, used in MS-DOS. Partitioned allocation. Memory is divided into blocks or partitions, one job per partition. Page memory management. Memory is split into fixed size pages and frames, eliminates external fragmentation. Segmented memory management. Memory is split into logical segments like function or array, require a segment table for tracking. Each method has its own use case depending on the system requirements. Let's transition to the terminologies. Let us now move into some important terms used in memory management. So it will be helpful for the further lecture that will be concluded by my fellow classmates. Let us now discuss swapping first. Swapping is temporarily moves a process out of RAM to a secondary storage and later back in when we need it. Benefits included of the swapping are higher degree of multiprogramming, dynamic reallocation, better memory use. This helps prioritize tasks and maximize system efficiency. Next up is a common issue in memory management, which is fragmentation. The term fragmentation, there are two types of fragmentation: external fragmentation and internal fragmentation. The external fragmentation is free memory is broken into small non-contiguous pieces, and the internal fragmentation refers to allocated memory contains unused space. External fragmentation can be minimized by compacting memory. Internal fragmentation is reduced by using the best size partitions. One solution to the fragmentation technique is another terminology known called paging. Paging divides memory into fixed size blocks called frames and pages. Key advantages of paging are reduces external fragmentation, simplifies memory allocation, makes swapping easier, boost data access speed. Because all the page and frames are small size, it keeps memory management simple and fast. Next, let's look at the segmentation, which is similar to paging but more flexible. Segmentation divides memory into variable size blocks called segments like code, stacks, or data. Each segment has a segment number and a length. The OS uses a segment map table to manage them. Unlike paging, the segments are based on logical division of program. This makes it more programmer friendly and ideal for modular designs. To wrap up, that concludes my presentation on memory management in operating system. We saw that memory management is what memory management is, why it is so crucial and essential, the techniques used, and some key terminologies. Thank you for your attention.